In this example, we're going to figure out the other 5 trigonometric functions. We're given one of them, and then we're also given a constraint. So this lesson is actually kind of like a combination of 2 things we've already learned. We're going to be using that ASTC chart to figure out which quadrant we're going to be working in, and then we're going to use the other information that we have to draw a triangle, and then we'll be able to figure out the rest of the trig functions. So the first thing you want to do is figure out which quadrant we're talking about. So I'm going to do this and make my chart. And even though it looks a little bit different than it did before, I actually do have 2 pieces of information. The first one is it tells me that cosine of theta is 4 over 5. So it doesn't tell me in an inequality, but I can see that 4 over 5 is positive. So I know that we're talking about cosine being positive. And then for tangent, it says less than 0, so that means negative. All right, so let's talk about where cosine is positive. Cosine would be positive. Everything is always positive in quadrant 1, and then cosine is positive where there's a C for cosine. And then we're also going to talk about where tangent is negative. So tangent would be negative in the places where it's not positive. So it would be positive where there's an A and a T, so that means I want to look at the S and the C. So now I can see that I'm going to be working in quadrant 4 because that's where I have both a red circle and a blue square. All right, so I'm going to draw a right triangle in quadrant 4. And of course, our theta is going to be the angle that's at the origin. Now, this is a little bit different than what we had before. Before, we were given an ordered pair, and then we could figure out our x and our y from there. This time, I'm given some different information, and there's a key to knowing where to put this stuff. And the key is that you have to remember that cosine, and I'm going to write it in this gray box over here, cosine is x over r. So the information I was given is that cosine is 4 over 5, so that means 4 is x and 5 is r. So my x value is always going to be on the horizontal axis, so that means my x value would go here, and I'm going to label it as x. And then my r is always going to be the hypotenuse of my triangle, so that's going to be 5, and that's my r. And then I'm going to be able to use Pythagorean theorem to figure out my third side. Now, we can't use that shortcut Pythagorean theorem because that one was just for when we wanted to solve for r. So we're going to have to use one that looks like this. X squared plus y squared equals r squared. I know that x is 4, y is what I'm looking for, and then r is 5. So I would have 16 plus y squared equals 25. And then if I subtract 16 from both sides, I get y squared equals 9. And then if I take the square root of both sides, y is equal to 3. Now, one little detail here. My y value is equal to 3. However, because the triangle is going down, that means that we're going in a negative direction. So even though I came out with positive 3 when I did Pythagorean theorem, you have to look and see what makes sense for the triangle that we are looking at. Okay, so last thing we need to do before we can just fill out the rest of these answers, I want to go through and fill out the ratios like this right here, the x over r. And these, again, are things that you should eventually have memorized. So hopefully you do already, but if not, I'm going to write them down again. So sine would be y over r. Cosine we already talked about is x over r. Tangent is y over x. Those are the main 3. Now you just have to flip them. So cosecant would be r over y. Secant would be r over x. And then cotangent is x over y. Now what's nice about these problems is if you didn't notice it right away, you might notice it once you start filling in the blanks, but we were given cosine. So we're given 1 out of the 6. Cosine and secant are reciprocals of each other. So if I know cosine is 4 over 5, I automatically know secant is 5 over 4. So these are kind of nice. You automatically have 2 right answers out of the 6. All right, let's go back to sine. So y over r. Oh, and I didn't label my y on the triangle. So my negative 3 is the y. So sine would be y over r, so that would be negative 3 over 5. And then I can just go right ahead and flip that. And remember that the negative doesn't, even though it technically goes with the 3, we like to just write it out in front instead of putting it with the denominator. That looks kind of funny. All right, and then tangent is y over x, so that would be negative 3 over 4. And then if I flip that, remember the negative just kind of goes out into the front, and then it would be 4 over 3. All right, we've got the same situation here. I'm going to first figure out what quadrant to draw my triangle in. So here's my ASTC chart. The cotangent that I have here is 24 over 7, and that is positive. And then it tells me that cosine is negative because it's less than 0. Now let's go back to cotangent for a second. Cotangent and tangent are partners. So when I'm talking about cotangent being positive, we can actually think of it as it being tangent is positive. All right, so let's go through and figure out what quadrant we're in. Tangent would be positive in quadrant 1 where everything's positive, and then also in quadrant 3 where there's a t. And because we're talking about cotangent and tangent, they have the same signs. All right, so cosine is negative. So I would think about where is cosine positive? Well, cosine would be positive where there's an A and a C, so I want the other two. So I'm going to put a blue box around S and T. And then I can see here that I'm going to be in quadrant 3 because that's the quadrant that got marked twice. So I'm going to draw my triangle in quadrant 3. And now we're going to go back and figure out some of our sides. So it tells you that cotangent is 24 over 7. Hopefully you have it memorized that cotangent is x over y. So now if I go back to what I have here, that tells me that 24 is x and 7 is y. So I'm going to write 24 here and 7 here. Now I know that it tells me that they're both positive, like that's what it looks like, but if you look at our triangle, they're both negative directions. So I'm going to write negative 24 and negative 7. And you might be wondering, well, why isn't the cotangent negative then if both of them are negative? The reason is because if I do x over y, that would be negative 24 over negative 7. These negatives cancel each other out and turn it positive. So because they're both negative, it makes the answer to the cotangent look like it's positive. All right, so these are my x and y. And then I have to use the Pythagorean theorem to figure out the value of r. And this one I actually can use that shortcut where we did r equals the square root of x squared plus y squared. We didn't get to use it in example 1 because we weren't looking for r, but now we are, so we can. So I'm going to write r equals the square root, and it's negative 24 squared plus negative 7 squared. If I put this into my calculator, it's going to give me 625 under the radical. And then if I take the square root of 625, I come out with exactly 25. So 25 is r. This one I don't have to worry about it being positive or negative. R will always be positive. It doesn't matter what quadrant we're in. All right, so we are all set up now. I'm going to go through and write down all those ratios again that hopefully you have memorized. And then we'll fill in the blanks and be done. All right, so sine is y over r, which means cosecant is r over y. Cosine is x over r. That means secant is r over x. And then we already talked about cotangent being x over y. That means tangent is y over x. All right, so now all we have to do is plug stuff in. All right, so sine is y over r. So that would be negative 7 over 25. I don't have anything to reduce or simplify, so that's it. Now if I take that and I flip it, I'm going to put the negative sign out in front, and then I'll have 25 over 7. Cosine would be x over r, so that would be negative 24 over 25. Secant would be the reciprocal of that, so negative out in front, and then 25 over 24. Tangent, I don't even really have to look at my triangle because I can just take my answer for cotangent and flip it. So I know that my answer is going to be 7 over 24. But again, I just want to mention really quickly, if we had done this from scratch, y over x would be negative 7 over negative 24. And because I have two negative values, they cancel each other out and turn positive. So even though both of my y and my x are negative, because I have two negatives, it becomes positive. Same situation, this one looks a little more complicated because we've got a radical. So let's figure out what quadrant we need to draw our triangle in. So I have two things. I have that the cosine of theta is square root of 3 over 2. It is positive because it doesn't have a negative sign in front of it. And then I also have that the sine of theta is positive because it's greater than 0. So this one, you might be able to just tell me that it's going to be in quadrant 1, but let's go through it. So places where cosine is positive, quadrant 1 where everything's positive, and then the C in quadrant 4 stands for cosine being positive. And then same thing for sine. Everything's always positive in quadrant 1, and then we would also be positive in quadrant 2 because that's what the S stands for. So I have 2 marks in quadrant 1. That means that's where we're going to draw the triangle. So I'm going to draw a right triangle in quadrant 1. Theta goes at the origin. Now I have to go back and remember, what does the ratio look like for cosine? The ratio for cosine is x over r. So I have my 2 values that I can label. My x is going to be on the x-axis, and then r is the hypotenuse of my triangle. So we do have to figure out our third side. Our third side is actually our y value. Let me mark these, x, y, and r. So since it's our y value, we can't use our shortcut for the Pythagorean theorem. We have to do the whole thing. So I'm going to use x squared plus y squared equals r squared. All right, so x is the square root of 3. And then I have plus y squared equals 2 squared. When you square a square root, they cancel each other out. So all that's going to be left from this is just a 3 plus y squared. And then 2 squared is 4. So now I'm going to subtract 3 from both sides. And that gives me that y squared is equal to 1. And if I square root both sides, I get that y is still equal to 1. So I'm going to label that right here. So I have all my sides. Everything in quadrant 1 is positive, so I don't have to worry about adding negative signs to anything. And now I'm going to go through and fill out those memorized ratios, and then we'll fill in the blanks and be done. So for sine, I know that it's y over r, which means cosecant would be r over y. We already talked about cosine. That's x over r. That means secant would be r over x. And then tangent is y over x, which means cotangent is x over y. So now we just have to go through and fill some things out. The trick here is that we do have a radical as one of our sides. So anytime that square root of 3 is in the denominator of our fraction, we're going to have to do some rationalizing. Okay, so for sine, I need y over r, so that would be 1 over 2, which also means that I can figure out cosecant. That would be 2 over 1, or I could just write it as 2 because anytime there's 1 in the denominator, it's unnecessary to write. All right, I have cosine already. I know that it's the square root of 3 over 2. So without even looking at my triangle, I can tell you that secant is going to be 2 over the square root of 3. But here's one of those problems where we have to rationalize because I can't leave the square root of 3 in the denominator. So what I'm going to do here is multiply by the square root of 3 over the square root of 3. And I'm going to end up with 2 square root 3 over 3. So that would be my final answer, what's written all the way to the right. Now let's look at tangent. Tangent is y over x. Y is 1. X is the square root of 3. So again, I'm going to have to rationalize, and I'm going to do it the exact same way. Multiply by the square root of 3 over the square root of 3. 1 times the square root of 3 is the square root of 3, and then my denominator just turns into a 3. So that is good enough there. Now for cotangent, I don't want to flip this fraction right here, because if I did, I would put the radical back in the denominator, and I'd have to rationalize again. So what I'm going to do is take this fraction right here and flip that one. So I'm going to take the square root of 3 over 1, and again, because I have 1 in the denominator, it's unnecessary, so my final answer for cotangent is just the square root of 3.